Okay, we'll get started, okay? I already sent notice to Kingston. I hope he will join soon. Okay, last time we get started to discuss the linked list. Okay, so linked list is actually a list built by linked node, and each linked node has a value and link. So this value can be an object, can be a data field, can be anything, okay? And then there's a next field to connect it to the next one. So that's called linked list. And there is a head. That's a pointer to the first node. Okay, so these are the basic structure for linked list. And we talk about it and then talk about the advantage, disadvantage. We cover it. And then we talk about the node class. Okay, so node class is the single data node. And we demonstrated by a integer, but you can use a T type. Okay, you can build it as a generic data type. So that's okay. We cover that. Okay, then linked list the function is similar to array list. Okay, so not much to talk about here. Okay, even though we have a lot of slices, but it's okay. Everything that you have, add first, add last, remove first, remove last. Okay, this everything that array list has, it all has. Okay. So that part we don't waste time on it. And then there are operations. Operation is a linked list of T type. And you had a constructor right here. And then there are basic function you need to implement. It's empty. Okay, so right here we have the whole implementation for the linked list about each of the function. And we don't have that much time. So this year we don't go to rewrite every single function. Okay, I just tell you that if you need a function, insert, delete, whatever, here we do have the implementation for you. Is that okay so far?
Yep.
Yeah.
So you can check the textbook and download the sample code. They do have this different function, remove, whatever. Because if I write all of these, it may take me like 3 hours maybe. And it doesn't make sense, okay? And here, one more thing, okay? The next one is the iterator. Iterator, we do not cover it before because array list, we do not implement the iterator. So this iterator, let's actually spend some time. So iterator, you actually need to implement iterator and iterable, okay? Iterable is a interface. An iterable must have an iterator function. So you need to implement both iterator and iterable. Once you implement iterable, then you have three functions, has next, and remove. This is three function. So if you implement these three function, then you will follow for each, that's a node, n, okay, and then n list. You put into the for each loop, then iterator will be able to access every node. So for each loop must have the iterator. Anything that you actually want to use for each loop, it either an array or a list, and it must be iterable. If it is iterable, then these three function is available, and then you can use them to get your next data. Okay. So that's the iterable. But here is the implementation as well. So anyway, because most of the function is similar to the array list, so we don't repeat that, okay? And then next one, before we go to the other data collection, okay, we may go to the data collection, other data collection today, but before we go into that, let's do one thing. Let's go to the user code. Not this one, I'm sorry. Let's go to the equal training site. And let's look at the section 1.2, the last problem for section 1.2. The ECHA problem is the last problem. This is broken linked list. Let's work on this one. Okay, let's look at this broken linked list. This one is related to list. Okay. So this one called broken neck list is related to this. In the past, I use array list to solve it. Sometimes I use array, sometimes I use array list. But today I'm going to use a linked list to re-implement it. Okay, I'm going to use linked list to re-implement to demonstrate the use of linked list and also to solve this problem. Okay. Now this neck list, this problem you have a neck list. So neck list is a line that connected several bit. Okay, each one is a bit, B-E-A-D. Okay, a bit, a ball. So you actually have a neck list that has many bits, and then they are connected by a string. So it connected by a string like this. Okay, so you make a circle, and then there are three colors. The three color is the red, blue, and white. So you may have red, blue, and white. Okay, so this one only red and blue, red, blue, red, blue. This one red, blue, and white. Okay, whatever. They are three color, red, blue, and white. So you are given a string, linked list string, and the data is like here. You have 29 of them. And then each one of them, the color is like this. So it's actually like W, 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 B, B, R, B, B, R, W, and then continue, and then to the end is a R, R, B, and then this B is supposed to be the last one, but these two are connected because it's actually a necklace. Necklace, okay, it's a necklace. So it's a circular data. Okay. Any questions so far?
No.
No.
Okay, now this is a necklace data. So now what is the problem? So you read in the data like that, you simple input like that, and then what they want to do is that you have the red, blue, and white different bit in there. And then they want to see that you start to look at the necklace. And then that, for example, that you actually look at here. Here you have blue, and this one is red, this one is red. Red, white can be used as a red or blue. So in this case, you will use it as red. Then your blue here, you have two blue. Here you have one red, two red, three red, four red. So totally this is four red on the right side, two blue on the left side. So this one, the possible maximum run would be 6. Okay, that's the one that they look at. They want to have the continue red, 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 blue, 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 one side red, one side blue, and see what is the maximum run or block of such bits. So that it has the continue one red color or blue color on the one side, red color or blue on the other side. But these two colors must be different. That's the goal. So, but when you have the white can be the red or blue. Okay. So in this case, here it looks like it's using as a red is better. Okay. But depends. That is white, it can be blue this side, it can be red this side. It depends. Okay. Okay, so here is the question I have. Suppose you are break the necklace at some point, that means that you break here, okay? And then lay it out straight, then collect the bits of the sum color from one side to the other. So this side is red, this side is blue. And then see how many bits you can have for the maximum. But one side must be one color, the other side must be the other. So one side is red, the other side would be blue. Okay. So determine which point that they would have the maximum number of bits that can be collected. Okay. Okay, anyway. For this problem, okay, let me see. Kirsten, have you worked on this problem before?
Yeah, but like a really long time ago.
But how to solve it? Do you still remember?
I'm pretty sure I just because there's only 350 at max, so you just loop through all of them.
No, it's wrong. It's not just look through all of them because it's
Like,
actually it's a circulars.
yeah, so if you attach like if you make a copy of the string and like put it at the end and you go through the possibilities, like you go through all of the positions that you can cut the string off at, you can calculate the maximum.
Hmm. How about Jiang? Do you know work on this problem before?
I didn't solve it yet.
Yeah, you need to try to work faster, okay?
Okay.
How about Harrison? Have you worked on this problem before?
Yeah, but I did it the same way like Kingston did.
What do you mean by Kingston? What Kingston did? You don't know
Like
how he did it.
like I looped it through like I made a copy with the string and then I looped through like each character of the string and
Why do
like
you need to
adding
make a copy?
to use it like it so like I also have like the original one.
What do you mean by the original one? Why do you need to make a copy?
So I could also have like access to the original one if like ever in the program like have to change it.
No, you don't know how to solve it.
No, like uh so like I have like a like the string, right? And
Mhm.
then I loop through each of the characters
My
counting like
question is why you need to make a copy?
for this problem I don't necessarily think you do though.
You do. For this problem, you do need to make a copy.
The way
So you don't know why you need to be to do it. Okay, how about Stephen?
No, I have not solved this before.
Okay, you need to work faster. Okay. How about Kingston? Why you need to make a copy?
Because it's a necklace, so it loops back. So if you
Yes,
don't make a copy, then
that's the word I want to hear. You are working on a circular environment, so you cut here. So you basically like assume that this is www whatever. But sometimes you look at the maximum block if we covering this and here. Then if you cut it here and then you use the string using only www, you cannot see the maximum block across the boundary. So what we can do right here is that you do have this www. So up to here is one copy. You make another copy, you put it on the back. And then it look like you are, here you do have this. So right here, if you have this one and this is RRB, it will consider or take into effect of the boundary that across this cut line. So this is necessary. You cannot do without copy this one to the other one. Otherwise, you go through the whole thing, you still don't see the boundary effect.
wait, Dr. Chow.
Yeah.
Wait, but once you reach the last one, can't you just loop back to like the first index?
When do you? That's actually will make things more complicated. You loop back, but how long you loop back?
Until like the character change.
Until the character change, you actually sometimes you don't know how many block you need to do. This one is more convenient. You just continue to work on it. It's easier. You don't need to see whether it goes through the boundary. So you have an array, and then you look at the boundary effect. You start from here. You may start from here. You actually look, and then you go over. You need to come back to start. You may look start from here. You go to here, and then you may look back to start. You may come start here. You may look back to start. Okay, that's one problem. The other problem is that because you are looping back, it doesn't mean that you only go this way. You only go this way. You may check here, but you look this way, and then it will look back to here. So putting it on the side is actually a better consider. Here is one of their explanation. This one, if you don't connect it, eventually you may be able to solve the problem, but you take too much effort. Okay, so here, this one is an example of when there is a circular design, then if you look at the boundary effect, then make it 2 copies will be enough. And you connect it end to end, that should be enough. So why not 3 copies? Why is 2 copies is enough? Why not 3 copies? Houston, why not 3 copies?
You don't need up to 3 copies. If you just have 2 and start from the middle, then
Yeah,
you
so
can
why we don't need 3 copies? I know we don't need 3 copies, but why?
I don't know.
Because the maximum block is at most n, right?
Hmm.
You don't need 3 copies to make an n. There's nothing that will copy over here. It won't be this long.
No,
Because your
okay.
maximum is only n. So 2n will be guaranteed that the n is smaller than it, right?
Hmm.
Yeah, we are not. I'm not trying to find problem with anyone. We just discuss why when we discuss something, we want to know about why. We don't care who answer what. Okay. Everything is okay.
Yeah.
Key point is why. You need to figure out why this is better and why that is not as good. It doesn't mean that you cannot solve the problem the way you say. You may, but the problem is that you may take longer time to do it. Okay. Now, let's assume that this is okay, that you do have 2 copies, you connect them together. Right? Next one is that how can I detect the maximum block? And given that you have a R, B, B, or W, W, whatever, how do you detect the maximum block? This one for Chang. Do you have observation on this? Say anything that you observe.
What do you mean observed?
Observe means that something that you know that is good or is okay to do it. So tell me how to get the maximum block.
I kind of don't know.
Hmm?
I kind of don't know. I still like can't clearly understand the question very well.
You still don't understand? Okay, it's okay. How about Kirsten? How do you solve this problem then?
Go through the middle, like loop through all the possible points you can cut the thing and just use a for loop.
Okay, that's the way, that's the thing that I talk about observation. Observation number 1 means before you solve the problem, you need to look at the thing. Observation number 1 is that the maximum always happen on the cut points. So let's assume that you actually try to cut here. Here one side is red, one side, the other side is red. This one you don't need to look at it because the answer that you want to look at is R, B, 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 B. You want to cut it and then you got the one side red, one side blue. You want to see something like this. So it won't happen that the maximum happen on here if you had a cut right here. It won't happen that the cut will be here. So that means cuts can only happen on color change. That's the observation number 1. Observation, what you see. So before you solve the problem, you need to come up with some observation. You know this is the way that should be done. That's called observation. Jiang, is that okay?
Sort of, yeah.
You look at the problem, you may not solve the problem yet, but you need to observe it, knowing that, okay, this will happen. So right here, at least I know the maximum will only happen on the cuts. Okay, that's rule number one. Now, number two. Harrison, do you have anything else to add? Other observation?
No.
So how, if I told you the cut is right here, how do you calculate the maximum run that you can have?
I would put like a loop, but I'm not sure if that's optimized.
Yeah, it doesn't need to be optimal because you need to collect every cut's block size. So that's when you look at this cut specifically. How are you going to calculate it?
Like I would do like a while loop and then like add like a counter to it.
A while loop? No,
Like while the next letter is the same as this letter.
no, it's not one while loop, it's two while loop. You need to look at right and look at left. So right side you have blue. Left side you have red. See how many red you have. You actually continue until you see a blue. This one you continue until you see a R. Is that okay?
Yeah.
But you sum up the left side and the right side, that is the block size that you get. Let's assume that you got a block size here. And then you look at the next cut. So your next cut is right here. So you every cut has a block size, and you figure out the maximum one. Then that is the maximum you want to have. Then you report the maximum. Then the problem is solved. Is that okay?
Yeah.
So let's assume let's me pick another example. Let's assume that you have www, r, www, blue, r. Let's assume here you do have a blue. Okay. So let's assume you are here, then your first cut is right here. This is 2 plus red, 3, red. So this one is 9 red. So this one is 11 on this cut. Okay, and here you see a blue. Now you actually cut right here. This side you have 2 plus 3, you got 5. This side you have 3, also 6. So this cut is also 11. Then this one you look at this cut. This side you got 6. This side you got 6. So this cut is 12. So let's look at this cut. This side is 9. This cut right here is 3. So this cut is also 12. Let's look at this cut. This cut right here is blue. So this one 6. This one 2. So this cut is 8. That's it. You pick the maximum, this one or either one. So the problem is solved. Is that okay?
Yeah.
So what I am teaching you so far is, number one, you need to look at the problem. When you start a user code problem, you need to look at the problem, formalize it. Formalize means that put it into letters. So put it into letters. And then observation number one is that you need to connect them in both ends. Observation number two is that it will happen on cuts. Observation number 3 is the maximum will be calculating the maximum of each cut's runs. And then you start to draw diagram, and once you think that this will solve the problem, then that is okay. Then this approach is a hard solution. Is that okay?
Yeah.
Okay, so that's what we teach you when you look at a problem, how to use sub-problem. You must make a observation. If you don't see anything, you are out. You cannot solve the problem. Okay, you must make an observation, and those observations will help you to organize the problem. So you put down those observation on notes, and then think about it, and then start to draw diagram. And then once you see the diagram, so once you can do the same as me, you put an example, you put on the paper, you put an example, you start using the paper solvers to solve it by your brain. You start to do it, doing one by one. Don't need to be a big example, small example, okay? You start to solve it and using cut maybe 12, maybe 11, whatever. You start to solve it and you see, oh, this actually can solve the problem. Then you start to do go coding. Kids, is that okay?
Yeah.
That's the part that I say planning is very important. Usually this planning, if you have a half an hour times, you want to solve the problem, this planning may take you the first 5 minutes. So for the first 5 minutes, if you can see the solution, you probably will solve it really quickly. If the first 5 minutes you don't see anything, you make no observation, you cannot see anything, I will tell you this problem, you may need to change another problem. This one, you may not solve it first. You may solve other problem and then come back later for this problem. Is that okay?
Yeah.
Don't get blocked by a problem for 1 hour and then you are done. You are basically out. Okay? Okay, anyway, now this is problem solving. You need to be able to use your diagram and your brainstorming to solve the problem. Once you see it can be solved, next one is that, okay, now let's actually do coding and make the cuts, make the cut list, and then organize the data structures so that we can solve the problem. So this one, as I told you, I will use, you can use different language, different data structure, you can do anything. But this one, I'm going to use linked list to solve it, okay? And in fact, I never used a linked list before. I used array list, I used array before. But this time I'm going to use linked list to solve the problem. That's number one. Number two, we'll be using the cuts. Now, let's assume that you have www.rrr.bbb. Okay, how do you organize the data so you actually, when you calculate the cut, and then calculating this number of the bits will be faster. So that means if you look at this cut right here, every time you look at the R, that will waste time. Every time you look at the W, it wastes time because you do it here. Next time you come to here, you still count many R here, many B here. Next time you come to here, you count many B here, many R here. You actually look each index, that's take too much time. So how to organize the data in a more efficient way?
Like store it in a chunk.
Hmm?
Store it like as like 3 R's or 3 W's or 3 B's as in a chunk.
3R, 3B, okay. So you can encode it by 3R, 3B, 3W, something like that.
Yeah.
Okay, now that's the idea, but we don't implement it that way. Okay, we will use a different way to solve it. Now let's get started for the coding, okay? You see, I actually do a lot of planning before I do coding. But I'm going to use a new project. So this one, let's call it chapter AB, okay? So this is chapter AB. I may need to, this one is called, this problem is called, let me see. Problem name is called beats, B-E-A-D-S, okay? Let's use that class name. And then I need the template, okay? So you need to prepare template every time. So you can copy the template without recording it from scratch, okay? So that's my template. Anything that we do before. So here we do have a gift. So let's look at this gift.java. Okay, that's me open with Notepad++. Okay, let me copy this whole file. Copy. Go to this bits. Put it right here. Okay, multiply 4 locations. So it's here the task, class name, input output. Okay. Okay, after that, you need to delete the unnecessary part that's actually not related to this problem. Okay, we are ready for this step. Okay, so let's say next one is preparing the input text. So this input text, let's actually create a new file. Okay, and then you want to put in the string and number so that you just copy from here. You have the 29 and the string. Let's do it. Okay, that's done. Let's actually save as. Okay, you need to go to the chapter AB. Now this should be chapter AB. So this one change it to all file, not normal text file, all files. And then use bit.in. Okay. Now everything is ready. We are ready to run. First one, you want to have the integer n will be input.next. Okay, and then you have a string. Okay, I'm sorry, this should be next integer. And then your string, let's call bits equal to input.next line. You use next should be okay. It's actually next line, doesn't matter. Let's use next because I don't want to have an input fit through problem. Okay, I don't want to have this input fit through problem. So after that, we do print out these two numbers again. Okay. Okay, so I read it in, it's okay now. Next one, we duplicate the bits, so the bits plus equal bits. Okay, let's print out again. We duplicate it, okay. Okay, so this one, I think it duplicate right here. Okay, any questions so far?
No.
Nope.
Okay, so here you duplicate the bits and this one not needed. Let's take it down. Okay. Next one, we start to create the so-called cuts. Okay, so we create some cuts, and then the first cut, like we did it before, the first cut add a 0 there. Okay, before we do anything, then for integer I equals 0, I less than each length, I increase. Okay, so this one you are looking at your BBW. You look at whether this one is a cut or not. This one is a cut or not. So the last one, the last window you look at is this one. Okay, so this one right here, you have a window of 2, so this one -1. Okay, so if beats the character at I not equal to beats the character at I plus 1. Okay, then that's that at I plus 1. Okay, so this one is cut 0, this one's cut 1. Cut 1 is between 0 and 1. So you need to add this. Okay, is that okay so far?
Yep.
Yeah.
Okay, so this one is actually adding the cuts. And then at the end, you cut that add. You add another one that's beats that that means that you have this B, you have the BBWW. This one is 0 to 2, 2 to 4. This one you add another one. So your cut number are here, here, here. So a cut is from this to this, from this to this. Okay, so that's the cut numbers. Now you also want to know about each block's size. You want to also know about each block's size. So that's actually have another one that's also use linked list. Okay, so this one you may want to use linked list of string. Let's use colors. Okay, that's for colors. And then let's create another one. Okay, so you've got colors and size. Okay, let's don't do S. Let's actually one more stroke to take. Now you've got the cuts and you want to get the data for the color and size. So let's do for integer I equals 0, I less than cuts that size -1 is a window of 2. Okay, and then let's see. Index will be equal to cuts. Let's see. Here you should have index 0. You have index 1, 2 cuts. Okay. So your size would add the index 1 minus index 0. So that's a when you do have BB. This cut is 0, this cut is 1. So the size is, I'm sorry, this cut is 2, the size is 2. is 2 minus 0. So if you have WW here, this one's 2 on this cut is 4. So the size right here is the difference. Is that okay so far?
Yeah.
Okay. And then the color, how can you record the color? Color would be your string. Your string is speech. Okay, your index 0 locations color is your color for the block, right? Because if you have 0, B1, this one is a color for this block. Okay, now this is 2. So if you look at the 2's color is not this block. Okay, 2's color, index 1's color is not a color. It's actually index 0's color is a color. Okay, anyway, we prepare the size, color, and the cuts. Let's print them all to look at it. In the competition, I don't do this, okay? I don't do this. I don't have time to look at the color, cut, size. Here, we just want to make sure, don't want to make mistake. In competition, nobody has time to do this, okay? Don't waste time to print it here, there, to waste time. Unless it went wrong. Okay, so here, cut the 0, 3, W for 3, B for 2, R for 1. Let's look at it, okay? Let's look at is that the data that we wanted. Let's look at the string. W3, B2, R1. Okay. W3, B2, R1. Is that okay? Is that okay so far?
Yeah.
Now, up to this point, I think we prepared the data structure correctly. It's time to solve the problem, okay? So you should be able to solve the problem up to this point. I already organized the problem to a way you'll be able to solve the problem. Okay, next one is going through every cut, look at the left and look at the right to see the maximum size. Okay, now let's do it. Let's still do it. Okay. This one, next one, we are going to look at the maximum cut, but it's possible that you have a red, and then you duplicate it 2 times. It's still red. So the maximum size you found maybe is 2n. If it happened that it's 2n, then your maximum size is limited to n only. That's what it say. Is that okay so far?
Yeah.
Okay, that's the part, optional part, actually critical part you need to have, okay? We don't want to make mistakes. So now here we are going to calculate the maximum n, okay, maximum n. So this one is also window of 2 because every time you have 2 numbers for the cut, okay, you have R, B, so you have 3 cut, these 2, these 2 is 1 cut, okay? is 2 as 1 cut. These are your cut numbers. Oh, I'm sorry. This one is wrong. No. I'm sorry. Let me take it back. So this one, you have R, B. You want to look at maximum cut. So what you need to look at is right here. That's one cut, left and right. You don't start it from here. You don't end it here. You only look at the middle one. So what you really need to have is R, B. Let's do W, R. Let's assume it. You actually look at here. So this is 0, 2, 4, 6, 8. So you only look at this is 3, this one. Okay. So what I make a mistake here should be I starting from 1. Cut is actually size -1 up to the one before the last one. Okay. Okay. And then I increase. Now, for each cut, you actually will have a counter. Okay, counter will be 0. You have a counter will be 0, and then this counter, no matter what you calculate, if the counter actually greater than the maximum, the maximum will be equals to counter. Okay, that's actually is the structure to find the maximum. Now, looking at the cut, let's assume that you have a cut I right now. You look at the back and look at the right. First thing you need to get this color and this color. Okay, so this one, let's assume this one is cut I. Cut I's color is this one. Okay, so you need to get the cut I's color and then the one before it. Okay, so you should have a string color 0, let's call it C0 equal cuts. No, let's use equals color that get I -1. That's the previous box color. String cut 1 equals to color that get I +1. Oh, no, this is I. So you got these two color, and you want to look at the different cases. So this you have 3 color. You may have R, B. No, you cannot have R because it's a cut, so you cannot be R. So 2 color different, you can have only RB, RW, BR, BW, WR, WB, 6 possible cases. Is that okay?
Yep.
Okay, you have 6 possible cases. Okay, you just look at the left side. If the left side is red, then the right side, because the W must be used as the right side must be using blue. Okay, the block you check on the right side must be blue. Okay, so if the left side is a blue, right side must be red. Okay. Here okay. Here you can use else, so you don't need to check the color again. So this else part means that it's not red, not blue. It must be W. So when you have a W, then you check the right side color. Okay, so this one C or C1 calculation is done. You know each cut, left side and right side's color what should be. Okay, and it's impossible that there is a WW, impossible to get W. It's also impossible to get BB or RR. Okay, so this one done, the C1, C0 represent C0 is the color on the left should be. C1 is the color on the right should be. Now we are going to calculate how many left sides blocks matching the C1. Okay, so let's do it. So right here, let's actually go back to the cuts. So you have a R, R, B, B, let's actually W, W, R, R, B, B, W, W. Let's assume it. Okay, and let's look at this cut. So you determine left side is red, right side is blue. Okay, this is C0, C1. So right here, you will cut, this is cut 0, 1. This is cut 0. This is cut 1, cut 2, cut 3, okay? And the index is 0, 2, 4, 6, 8. So right here, you are looking at the cut 2. Left side is cut number 1, right side is cut number 2, okay? So this one, you cut right here, I, this is I plus 1, this one's I minus 1, okay? So you will get started, look at the left side, you started at the I minus 1, okay, and you cannot get out of bound. So let's do it. Okay, you want to look at the left side, so you do have the RR, WW maybe like this, and you are right here. So your I right now is 2. You go to look at I equals 1 and I equals 0 for the colors. So if the color is the same as the C0, or the color is white, that means you can continue to look at the next one, okay, until your P actually is greater or equal to 0. P less than 0 is not okay. So now let's actually have another number here. Let's do left side. Okay. So here, left side that plus equals to size bracket P. Okay. And then P minus keep decreasing and check if the color is compatible. It's either the C0 or W, C0 or W. Okay. Then let's look at the right side. Right side integer to Q start from equals I. Okay, starting from this number I. Okay. Then you do right side, you have the right size starting from 0. Then while Q less than the last one. Okay, so you actually keep doing it until your last cut. Let's cut each one. You actually, so it's less than equal to, let's see. So your last cut is, let's assume that you have WW, RR. Your last cut is right here. If you use the cut size, then the last cut do not have a color. Okay, so you need to be the one before it. So let's don't use the color, let's use the size. I'm sorry. Okay, we still need to use color cut. So let's use cut -1. Okay. Okay, that's one we can do. And these are the same, similar, not the same, similar. Okay. So right here, one problem, this must be changed to Q, otherwise we will be in trouble later. Okay, almost done, okay, almost done. So this is checking on the right side to get the size and then Q increase. So you have the right side size and left side size and total size. So let's do system about a twin line left plus right plus left plus right. Okay. Then your count is equal to left plus right. Okay. I use the left or right to give you the idea, but in fact, you can directly add to the count. Okay. Now this one, if no bug, it should be done already. Okay, let's see what happened. Okay. index out of bound. Index out of bound. Color get P, color greater than 0. How comes this index out of bound problem? Okay, let me do this. Okay, let me take this one out. We'll check it later, okay? Up to here. Up to here, okay? So right here, we actually go up to here. We calculate the left side color, right side color. Let's print it, okay? Debug it. Something's wrong. Okay, let's see these two colors. No, I'm sorry. Let's do this. Let's do just print these. Okay. Okay, print out the color, and at the end, let's print the new line mark right here. I think the coding is done, but something is wrong in the middle. So let's see. Let's check, okay? So here, let me point out this one. So right here, this one is WB, this one is BW, this one BW. No, that's wrong. I'm sorry, that's wrong. This one BW, this one BW. Wait. Why come this actually has two of them? Something's wrong, okay? Something's wrong. It should be only WB, it cannot be WB, BW, RB, BR. This one is RB, cannot have the BR again. It should be BR, not RB. So something's wrong here. Let me check, okay? Let me check. Something's wrong here. Let me check. So you get the color of the two sides. You use a I-1. If R equals R, you change C1 to B. And you print this. The next one, you go to the next cut. Okay, let me do one more things here. Also print out the I number. Okay, print out the I number so we know that which cut it is. So here, this one's 1, 2. Okay. So how come 2 is equal to BW? 3 is RB. So let me see how many are there. Totally 46. Okay, let me see. I think the setting for the C0, C1 should be wrong. So here you are getting color at so you starting from I equals 1, you get the C0 and the C1. If the 0 equals red, C1 equals, oh, this one a mistake. This one should be blue, it should be red. I put a W, that's wrong. Okay, I make a mistake there. This one should be W. I make a mistake. Okay, just a typo. It's blue, should be red. Okay, let's look at it again. It's actually the wrong coding. Okay, I use the wrong coding. That's a typo. So ERRB plus C. So it's actually WBBR, WBBR, RB. Okay, that's correct. Okay, that's correct now. That's correct now. This actually coding is correct. Let's look at the end, making sure that you cover every single color even to the end. Right now, I'm more careful because this is to show you what it is. So I need to be more careful. So last one is RB. Let's check. Last one is RB. Okay, last one is RB. So this cutting now is okay. Now we can actually take out this line. Okay, take out this line. Now let's actually looking into, let's don't calculate the right side yet. Let's look at the left size each time. So go into here, we go to calculate left side, right side, I'm going to commit it out. Right side, I'm going to commit it out. I only calculate the left side. So the left side, each time we want to calculate the left side, starting from I minus 1. So I is 1 right now. Okay, it gets 0. So this one is said that it actually get out of bound. Let me see, okay, one more time, whether it will get out of bound or not. That's a print left. That's print left, okay? Here we have system.out.print line, that's actually okay. That's a print left. Okay, it actually do have that index out of bound problem. It do have the index out of bound problem. Let's check it, okay? So let's see, that's actually is I equal 1. So when we get in, it has the index out of bound problem. Let's actually look at system that out of print line. Let's print the P. Let's print out the P, okay, see where it break up. 0, it break up. It's just print the 0 and then it break out. It actually is a 0, it break out. Oh, okay, I'm sorry. This one right here need to have a parenthesis. Because you actually, the color is all should be together. So I make a mistake right there. Okay, now one more time, okay? Okay, now it get the data is what I don't know, but let's delete that. Let's delete that, let's delete the P part. We don't need this P part. Let's look at the left side. Okay, so left side is 3511. Let's look at it. 3511. So this one 3, this one 5, this one 1, this one 1. Okay, that's correct. Okay, that's correct. Let's look at the right side. Let's look at the rightmost one. The rightmost one is RB. The rightmost one is 5. The left side is 5. Let's see. So this one is 2, 1, 2, 3, 4, 5. So actually it's 5. Yes, correct. The left side is correct. Okay. Now, left side is correct. Let's turn on the right side then. Suppose we have the same problem, we have the same error that I make, we would remove that first. So right here, you actually, that's okay. Let's turn on this right side. First I start from Q, because right here I put a, so now we don't need to print the left side, delete the left side printed. Now right side, that's it's okay, and you print out that right. Let's look at it now. Right side 0, right side number is wrong. Okay, right side number is wrong. Right side number is wrong. Okay, let's see. Oh, right side, I make a mistake. I copied over. This one should be changed to C1. It should not be C0. Okay, it's one error. Anyway, that's okay. Let's actually run one more time. Okay, now it's 11. Is that okay so far? Hello? So suppose this algorithm is correct now. I don't need this one. Let's delete it. I don't need this one. Delete it. Let's run one more time. Only have one output. Okay. Now next one, let's print it to the output file. So this one system.out, remove this. Okay, let me check the outside file. Okay, now, since these are done, it's time to submit the solution to the website to check, okay? I may not be the most efficient right here because I'm doing demonstration. I keep talking and also I try to print out, make sure there's no problem. If in the competition, a lot of things should not be done in the same way, okay? Should be more efficient. Test one, okay? Test 2, 3, 3, 3. Your answer is 0. Oh. Your output is 0. Your output is 0 because there's no cut. Okay, so the no cut problem, the max equals 0. Okay, let's do this. Let me add one more line. Okay, this one the same. Essentially, if you don't have any cut, you don't go into the cut to calculate the number of the elements. Okay, let's submit it one more time. That's extreme case because if you have only R, and 3, okay, that's when you have the R and 3, you will have the trouble. That's one same color but no cuts. But it's only one of the exceptional cases. So pass everything. Is that okay so far?
Yeah.
Okay, so what I'm trying to say right here is that number one, I demonstrate how to use linked list. It's the same as your array list, okay? And right here, we prefer linked list because array list, the main problem is when you do insertion deletion, it take more time. And this one, you do have a lot of add, right? You add cut, add color, add a lot of things. You add a lot of things, insertion, deletion, linked list is faster. Okay, so that's one thing we would like to use a linked list. Number two that I want to say is that this one is the cut-based design. So you look at different cut, and then you group the cut to the same color and same size. So there's a size, color, and cut location, 3 linked list being used. Okay, this is the way to use linked list. This 3 linked list, instead of every time you go to see if there's a www, then it take a lot of time to do that. Is that okay so far? Hello?
Yeah.
Instead of checking every W, that's actually, you may solve the problem, okay? I don't say that you won't solve the problem. You may solve the problem, but it may take longer time, okay? Now, next one is that for the color, you must know about what you want to do. So this adjustment for C1 and C0 will save time as well. You know that what is the left side color, what is the right side color. This is the key of the problem solving, one of them. And then knowing the while loop, using the simple while loop to keep looping to the BWDW things and while loop to the other side as well. That would also save time. You don't need to use the right, left, okay? You can directly use a counter and then counter increase every time. Right here, I just want to demonstrate how many left and how many right, okay? But it's not necessary, okay? It's not necessary. Otherwise, this program is okay. It's just a ad hoc problem, and it's actually a finding maximum problem, finding maximum at every cut problem. Only problem that this one make it more difficult is that you need to know that it's a circular design. So circular design, you duplicate twice is enough. Okay, twice is enough to solve a circular problem like this. Okay, and there's only one case that may make it break is that when you have the 3 of the same color, 4 of the same color, then there's no cut. There's no cut that you can find. It's only 0 and 1, and there's no cut. So your maximum will remain at 0. So that's okay. I found it, but it's okay. That's a boundary case. Okay. Okay, this is the so-called linked list example. Okay, linked list example. Now let's move on. Next one, we are going to talk to look at other data structure. Okay, let's move on. We need to continue. So along the way, we will learn more data structure and solve more problem, and each problem may have different technique. Those techniques may not be covered in the language, may not be covered in the program structure. You have to figure it out, okay? You have to figure it out. And which way to solve the problem, there is no fixed way. Right here, we only talk about good or bad, better or worse. I cannot say that your way is definitely wrong. I don't say that. I can only say that it's actually is not as good, or it's actually will be slower. Everything is okay.
Yeah.
But why we discuss faster and lower and then better, or that's because we want you to avoid the trouble. Okay, avoid trouble in the competition. Sometimes you avoid trouble because it's too slow. Sometimes you want to avoid the trouble because it's very difficult to code, right? Or take longer time. So for example, one thing that here I show you is like this one will save time. A few things that you here will save time. Figure out what is left side color and right side color will save time. Using color will save time because you will actually reduce the time you check every symbol every time. That actually too much. So you count them in a way. You count the W, how many R first before you look at the cut to look at it. Okay. That's the observation that I want you to make. So before you do coding, or you do competition, don't jump into coding. You have to make a few observations, figure out which way is a better way to solve the problem. Okay. Now let's finish up this chapter. Okay. So this linked list is a part of the collection. So you have array like this. Linked list is linked node. When you use them, they are both list, so their behavior is similar. But in terms of computation time and in detail implementation is different, okay? So linked list is data structure. List is called abstract data type. Abstract is a concept. List is a concept. Linked list is a data structure, is a structure of the data. You really need to put them into classes and everything to implement. That's called data structure. Is that okay? Hello, is that okay?
Yeah.
Yeah.
And there's another word called collections, library collections, or in C language, we call it standard template library. Okay, data structure, you have two parts. One is this kind of thing called collections. That means it actually is built-in. Built-in means that Java already created a linked list for you. Java already created a map for you. Okay, and C language has standard template library. You can call them directly. This we call it data collections. It's also part of the data structure, but data structure has another part that is unstructured, unbuilt. You build a tree, you build a graph. Those kind of data structure not supported by the library, we call it data structure, advanced data structure. So usually when we say DSA course, data structure and algorithm course, you should cover those unorganized data structure. If you just cover this collection, usually this is only APCSB, the part B data collection part of the APCS. Okay, it's different level. How much you need to learn? If you are CS student, you need to learn everything, okay? And right here, the collection, you have set, list, and map, 3 major types. And you have hash table implementation, you have balanced tree implementation, you have recessible array implementation, you have linked list implementation, and it ends up with so many different data structures. So list make of array is called array list. This make of linked list is called linked node. set made of hash table is called hash set. Map made of hash table is called hash map. Set made of tree structure is called tree set. Map made of tree structure is called tree map. Okay, this we later will cover this difference. Right now we cover only this and this. Okay, and later we will go into the more of the data collections. So you need all these different type you need to learn, and that will be set, map, list, queue, utilities. Utility is the service routine. So for the list and collection is called collection S. If it is array, it's called array S. Okay, these are the utility classes. Any questions so far?
No.
Okay.
No.
And here is the complexity. Okay, how much time it takes to look at it. Okay, this we will cover later. And then single linked list. We talked about single linked list already. Okay, this one. Okay. Cloning array to copy one array to the other. Okay, this one I assume is okay. It's the data that clone is okay. We covered it before. So there's one thing you need to know is shallow copy versus deep copy. Shallow copy means you just copy the reference. Deep copy means you go down to copy each individual data node. So let's assume that right here you have a array list of classes. Okay, let's assume this is array list of node. Okay, shallow copy. Shallow copy means that I want to copy this one, but each one of them has an object. So I only copy the reference. So this one pointing to here, this one pointing to here. So if this one change right here, it changes the content. This one will also see it because it's a shallow copy. Is that okay? You only copy the reference to the object. It's called shallow copy. If you have a list, and then the object, you clone the data of the object to create data right here. So this is one object, this is another object. You copy and also copy the object. That we call it deep copied. Okay? Is that okay?
Yep.
But there's a problem that you may have a linked list. It is an object, but inside this object there is another array. Under this array there are many objects as well. So when you talk about deep copy, is actually you have one level deep copy or two level deep copy. You want to have deep as recursion as the whole tree being deep copy. That's one way to do deep copy. And deep copy may have level 1, level 2, level 3, depending on how many levels you want to go down to do deep copy. So that's one thing that you be careful when we talk about deep copy. Is that okay?
Yeah.
Okay. That's the concept only. Okay, we don't waste time today. So when you clone the linked list, you need to know about whether you clone it for deep copy or shallow copy. Okay, right here we don't create those code. Okay, it's actually take too much time. Comparison of array and linked list. Okay, it's okay. We don't waste time. You do it. Circular deeply linked list, which only give you the concept. We don't implement them because in competition you never do it. Next one is the stream builder and stream buffer. So stream is immutable. You cannot change the content. Stream builder, yes, you can add data to it. Stream buffer, you not only add data to it, you also have the data synchronized. Okay. John, what is the synchronized data?
It's a data that is like synchronized between threads, I think.
Yes. So why we need to have synchronize data among the different threads.
Or there will be like a race condition and
Yes. Good job. The stream buffers essentially is safer, but it will take longer time because actually you do more of the security check. So what happened is that let's assume that you are a person. So you are here, you are actually access an ATM, right? And then you try to deposit and then withdraw money. Your wife, let's assume you have a wife, is sitting at the computer trying to withdraw and deposit money as well to the same account. Let's assume you do share an account. So in this way, if you multiply the data and this one is accessing, for example, you withdraw $100, but your wife assumes that you still have $1,000 and she tried to withdraw 1,000, then you will be in trouble. Okay? To solve this problem, you need to make sure this guy withdraw transaction finish before other people can access the data. So this is called synchronized data. Is that okay so far?
Yep.
Okay. So this one I just won't give you the idea, but the thing is that string buffer can be modified, string builder can be modified, and string buffer add more feature of the synchronization. Okay. That's it. I don't want to cover too much. So these are the functions for string builder, string buffer. I put it here because string builder, string buffer is not part of the AP now, but you do need to have them sometime. You have to insert, delete, character add. This everything that string can do, it can do. Okay, except that it add insert, delete character add. Set character add. These are the functions that string doesn't have, but string buffer has, or string builder has. Is that okay? Other than that, it's actually a string. Only you can add. You have this different one. This multiplication of the contents one are new function. Okay, it's for string builders. So here you compare the times of the storage. Okay, this one slow, this one fast, but this one secure, mutable here, immutable here. Okay, stress tab and synchronized. These two stress tab and synchronized. Okay, string builder not synchronized. This one synchronized because it's immutable. So whether it's a stress tab or not, it actually doesn't matter, right? Because by itself is immutable. It cannot be changed. Right? Is that okay?
Yeah.
It is not able to be, it's actually immutable. So whether it's actually synchronized or non-synchronized to string, it actually doesn't matter because I cannot be changed. So nobody will modify it. Okay. Okay, performance-wise, string builder is the fastest. Okay. So here teach you string concatenation is faster, string builder is actually second. Okay. This one means that you use the concatenation method. If you use a plus, this is slower, okay? Use the concatenation. That's why there's still a concatenation function. But I don't think usually the user care about this, okay? Anyway. Okay. A function for string builder, okay? Next one here is the iterator. Okay, here it has the converting this to array. Okay, there's a to array function. Okay, this one we talked about it before. So we an array to list using as list. Okay, this one we talked about it before. Iterator. Okay, iterator not very important in Java, but very important in C++. Okay, so you use the iterator for enumeration. and you have an iterator and the list iterator. So array list, linked list has a list iterator. Okay, that means you have previous, next, has next. Okay, those kind of functions. Okay, these are the functions for list iterators. Okay, I just cover these different functions. We don't have example for this. Okay, we don't have example for this. And just that you know, these are the features of the data type that we discussed today. Okay, next week we are move on to the stack and queue. Okay, let me see. Yeah, that's true. Next week we are move on to the next data structure. So let me see next week. Next week we are move on to stack. Okay. Any questions so far?
No.
Okay. One thing is that you need to keep competing. Okay. You may lose, but it's okay. Right now, losing is okay. It's actually welcome. As long as you keep yourself in the game, you may start it with cannot solve any problem to solve one problem to solve two problem to solve three problem. Keep doing it, okay? Initially, you may not solve even one problem. That's okay. Sitting there, knowing what is the pressure, start to learn how to manage time. That's very important. So next one is January 30 to February 2nd. Okay, the second contest. Is that okay?
Yep.
And right here, what I will do is that I'll continue to guide you through this gateway guideline because it covered the chapter 1 covered the whole brown to silver need. Okay, it's all here. It's different type of problem. I can only cover this part. In the past year, I also covered the past problem. We may do that from time to time, but primarily we are covering this problem online for the USA gateway because this one is well organized problem. We present each chapter, but you still need to work on a lot of the past problems because each year they add new problem type. Each year the problem difficulty is getting harder and harder every time. Okay, so I cannot cover every problem type for you. You need to figure out how to solve the problem in the middle of the competition. Okay, if you cannot do that, then you are out. You cannot compete. Is that okay?
Yeah.
We can only teach you the guideline, how to prepare yourself to be able to compete. But there are still a lot of things that you need to learn in the competition. Okay, in the competition to know about how to avoid trouble, how to debug when there's something wrong, how to solve the problem. Okay, those kind of things I cannot teach you in the class because how can I know that you will bump into what problem? You know what I'm saying? So those portions you need to stay there, try to solve it. If you cannot solve it, keep doing it after the time expires. You still keep doing it, making sure you understand each of the problem. Okay, Harrison, hear me?
Yeah.
This one is a long-term marathon. So it may take you half a year, even 1 year, or even 2 years to pass the first level. Okay, depending on how hard you try. The harder you try, the time that you need to spend on bronze level will be shorter. Okay, nobody else can help you except yourself. What I can do is only guiding you how to prepare yourself and how to train yourself. Okay, at this moment, you still need to try to follow all the problem in the guideline. That's one thing. Second thing that you need to do is also every week at least 3 problems. Okay, if you cannot set aside 10 hours to work on 3 problems, that means you cannot compete. Okay, if you want to compete, you must set aside those amount of time to train yourself. That's why it's so difficult. Very selective people who pass each one and very difficult. Okay. So for Kingston, how many people will pass the user code bronze every time?
Yeah.
Hmm?
How many people?
Yeah, you have the bronze to silver, silver to gold, gold to platinum, platinum to tin. How many would be promoted from bronze to silver every time? Do you know?
No.
So are they based on score or are they based on percentage?
It's based on like what score you got, right? I think this year is above 700.
No, it's not. It's based on percentage.
Hmm.
Jiang, you hear me?
Oh yeah.
So let's assume that they actually determine the bronze to silver. You have 5,000 people who competed this time. I would say bronze to silver, they set up a 10% threshold. So they will pass the 500. They will pass the 500 and then they will look at the score. So you actually from 0 to 1,000. And then 10%, top 10% maybe is 750. Then they will use 750. So next time, if the 10% move on to 800, then you will be 800. Is that okay? My kids, is that okay?
Yeah.
So that's why every time their pass score is different. They don't know which time, how high you will pass. So I would say this is silver maybe 10%, this gold level maybe 5%, this bronze level maybe 1%, something like that. They have a percentage. Okay, team is only 24 people. So that's the way they manage. They don't accept more. No, they don't. Okay? You must be as good as top 10% to pass. If you are not, no matter what is your SAT score, they don't pass you. Is that okay?
Yeah.
Hello,
Yeah.
hear me? That means right here we have 5 students, 4 students, 5 students. You are only 10% of them will be selected to the next level. Okay?
Mm-hmm.
That's why you need to work hard, okay? And these people eventually, usually you may go to elite CS schools, okay?
Yeah.
Okay, that's it for today. I just want to share some idea with you. Okay, good night then. Bye-bye.
Thank you. Bye.
Bye. Thank you.
Yeah.